Okay, so we've already talked about acceleration in regards to a velocity versus time graph. And of course, that's the lab we were just working on. Okay, but now we want to look at like acceleration in terms of being able to solve problems using the formula that maybe don't involve a graph. Okay, and understanding exactly what acceleration is. Okay, so in order to understand what acceleration is, we first have to understand what it means to not accelerate. Okay, the general tendency of an object is not to accelerate. Okay? The general tendency of an object is to continue doing what it's already doing. Okay, that's Newton's first law. Okay, Newton's first law is generally summed up in this single word: inertia. Okay, Newton's first law, while part of rocket science, is not rocket science. Okay, Newton's first law says that this desk will stay right there, provided nobody bothers it. Okay? Well, duh. Of course it's going to sit right there. Nobody's bothering it. Nobody's exerting any forces on it, so it's not going to accelerate. Okay? Are there forces acting on the desk right now? Okay? What forces are acting on it? Gravity's acting on it. Okay? Is gravity the only thing acting on it? Gravity's pulling it down. What's keeping it from moving down? The floor. Yeah. Okay. So there's actually two forces acting on this desk right now: gravity and the floor. And they're balanced, which is why the desk doesn't either fall through the floor or fly off the floor, which both would be weird. Okay. So that's Newton's first law. Okay. If there's a force that's not balanced, then the object will accelerate. Okay, so if I've got, my desk chair here, right now there's no unbalanced forces acting on it, so it sits still. But if I give it a shove, okay, it will accelerate, and then after I let it go, it starts to slow down again. Okay, because the only force acting on it after I push it is friction. That's why it comes to a stop. Okay, I mean gravity is there, but it's not unbalanced. Okay, so all these unbalanced forces are what cause accelerations. And an acceleration is any change in velocity. So, definition of acceleration: whenever the velocity of an object is changing, that object is accelerating. According to that definition, we can calculate acceleration by taking the change in the velocity and dividing it by the change in time. Okay? Because acceleration is, after all, the rate at which we change that velocity. Velocity is changing, the object's accelerating, but we can also calculate the rate of that acceleration. All right, so that's going to be meters per second divided by seconds. It's going to give us meters per second squared. Okay, and we already know that this formula here comes from a velocity versus time graph. Okay, on a velocity versus time graph, this would be my final velocity, this would be my initial velocity, and this would be time. Okay, that's where that formula comes from. Everybody all right with that idea? So a very simple example of an acceleration problem would look like this, like a word problem. Okay, so I have a plane that starts from rest. Okay, that's an important term to know. Okay, if something starts from rest, its initial velocity is 0 because it's not moving, it's at rest. What about if it comes to rest? So if something starts from rest, its initial velocity is 0. If it comes to rest, final velocity is 0. Right, okay? So Starts from rest, VI is 0. Comes to rest, VF is 0. Rest always means stopped. Right? So you kind of have to look at the context of the question to decide which one is going to end up being 0. Okay? The plane accelerates down the runway, and after 29 seconds is at a velocity of 72 meters per second. So we know VI, we know VF, and we know T. Can we plug into that formula and calculate the acceleration? Okay, if you don't have to manipulate it, we're being asked to calculate what that formula is set up for. Right, so we would have positive 72 meters per second minus 0 meters per second, because our initial was 0, divided by 29 seconds. Right? If we do that, we should get positive 2.5 meters per second squared. Okay? So what that means is the speed of that aircraft is increasing by 2.5 meters per second every second. Right? So at time 1 second, it will be going 2.5 meters per second. After 2 seconds, it will be going 5 meters per second. So on and so on. Okay? Everybody all right with that? Okay, let's look at some algebra here then. What if I want to solve for t? What do I need to do? Can I solve for t if it's on the bottom? I can't. So I need to move t. Where should I move it to? To the other side. How do I do that?
You multiply by t and then you divide by a.
Okay, so I've multiplied both sides by t. T cancels here. T comes over here. Okay? Divide both sides by a, because I want to leave t by itself. A comes under here. So t would equal VF minus VI over a. Right? That would be probably our easiest manipulation. Okay? What if I want to solve for VF? What should I move first? Okay, 3 rules in algebra. If I want to move something, I do the opposite. What I do to one side, I do to the other, and I move what's not attached first. What's not attached to VF?
T.
T. Right, so I need to move t first. How did I just finish moving t a minute ago?
Multiplication.
Multiply. Okay, so I multiply both sides by t. Okay, I want VF by itself. What do I do with VI?
Addition.
Addition, yeah, just do the opposite, right? I'm subtracting it right now. Okay, so here's why I want to show you that this makes sense logically. T times a equals the change in velocity, how much my velocity changes by. So if I add VI over to this side, I'm saying take my initial velocity, add the change, and I should get the final. That should make sense logically. Everyone okay with that logic? Okay, how does this change if instead I want to calculate VI? Okay, I could subtract VF. If I do that, what's going to happen to VI? It'll still be negative, which is okay if you can keep track of your positives and negatives. I'm old and forgetful, and I always forget and mess it up. Okay, so what I do is I actually do the same thing we did a minute ago. I actually add VI over to this side, and then I move t times a. Right now I'm adding t times a, agreed? Can I subtract it over to the other side? Okay. Okay. So now I'll have my initial velocity equals my final velocity minus the change. Okay, I went VI plus the change to get VF. I go VF minus the change to get VI. Does that make sense logically? It's like when you go to work and you don't have any money when you start. okay? And then during the day you make money, and at the end of the day, oh wait, that doesn't work because they take taxes and all that other crap. Okay, forget that example. Okay, because they take money away from you in the middle. Making sense? Okay, so that's the manipulations that we're going to have to know how to do, okay, to solve acceleration problems. All right, and as we said, what are our units for acceleration? They might be on the board. Meters per second squared, meters per second per second. They're the rate at which we change velocity, so meters per second per second. How many meters per second do I go faster or slower each second? Okay. Copy that one down and see if you can solve it. So first thing is we want to read the question and get the givens out of it. Okay, sprinter starts from rest. What did they just tell me? BI is 0. Okay, and reaches a velocity of 16, positive 16 meters per second. That's VF. How do I know that?
Because it says.
Yeah, I have to get it. It's like reading a story. I've got to do a little bit of, what do they call it? Reading comprehension. Okay, I've got to read that thing and understand the story. The other thing I can look at are the units. Okay, if something's in meters per second, it's one of the two velocities. Okay, and then it says it does that in 4.5 seconds. What is that? That's the time. All right, so find the acceleration. So we're looking for A. So you get a mark for that. Okay, you get a mark for selecting the right formula. I mean, you got a lot of formulas on your formula sheet. The reason we write our givens down is to figure out which one we want to use. Okay? I don't have to manipulate it. I just have to plug in my numbers. Right? So we would have positive 16 minus 0 divided by 4.5. All right? And then that will give us our acceleration. So 16 divided by 4.5. Okay? So we're looking at 3.6. meters per second squared, and I should put a positive on that because it is going faster. Okay? And acceleration is also a vector quantity. All right, everybody okay with that one? Give that one a try. We'll finish that one up before the end of class and then we'll call it a day. So the question wants to know how long it will take. What are they asking me to solve for? Time. Okay. You guys are getting good at this. Okay. How long will it take a jet to accelerate from rest? Right. Which one is 0? The initial. Right. To positive 85 meters per second. Well, that's kind of a no-brainer. If we know that one was VI, this one has to be VF. Okay. Meters per second. At a rate of positive 22, oh, what am I missing here? That would be confusing. Squared. Yeah, that's got to say squared on it. Okay, so the acceleration would be positive 22 meters per second squared. All right, so we're looking for how long that acceleration will take. So A equals VF minus VI over T is the only formula on my sheet that is appropriate here. Okay, I'm solving for T. So I multiply both sides by T and divide both sides by A. So I would have positive 85 minus 0 divided by 22, positive 22. All right, so we'd be looking at 3.9 or 3.86 seconds. How important are the units? Very. Don't put them on there, it's wrong. Okay, make sure you got units. I think we will skip the quiz tomorrow. I haven't gone over acceleration quite enough yet to quiz you on that, but we've done enough graphing ones that I'm going to skip that. So, you're not having a quiz tomorrow. All right.
Yes.